Hello everyone, good day. Welcome to the 8th topic of this course, IT 11. This is limits, continuity, and derivatives. Today, we will learn about the concept of a limit, the rules for evaluating limits, a one-sided limit, and we're going to identify whether a function is continuous or not. We're also going to learn about the derivative of a function, and of course, the rules for differentiation. So what is a limit? A limit describes the value a function approaches as the input gets infinitely close to a certain value rather than the value at that exact point. Take note of the word approaches and infinitely close to a certain value rather than or not exactly at that point. Ang application ani nganong mag-learn ta about limits, these are used in derivatives because limits are used to define instantaneous rate of a change of a function. Sa integrals pod ma-apply siya because limits are the foundation for both definite and indefinite integrals which are used to calculate areas under curves. And for continuity, a function is continuous at a point if the limit exists at that point. The function is defined at that point and the limit equals the function's value. So now that we understand what a limit is and how it tells us the value of a function approaches, let's make the process of finding limits easier. Instead of substituting values every time, we can use a set of shortcut formulas known as the rules for evaluating limits. These rules allow us to simplify complex functions into smaller, manageable parts by adding, subtracting, multiplying, or dividing their limits. So let's go through one by one and see how they make our calculations faster and more accurate. Let's start with some law for limits. We have here the limit as x approaches a of the function f of x plus g of x is equal to the limit as x approaches a of the function f of x plus the limit as x approaches a of the function g of x. So this means that if you're adding two functions together, you can find their limits separately and then simply add the results. In other words, the limit of a sum is the sum of the limit. So nagtotal rata diri or nag-add lang ta. So for example here, the limit as x approaches 3 of the function f of x plus g of x. So technically, ato lang i-substitute ang ato ang value nga na diri into here. That is why we came up with 9 since 3 plus 2 times 3 is just 3 plus 6 and then it is equal to 9. But later on class, we will also learn na dili di ay sa tanan case na pwede ta mag-direct substitution. Case-to-case basis siya. Depende sa dagway sa inyong function. First, let's proceed with difference law for limits. So we have here the limit as x approaches a of f of x minus g of x is equal to the limit as x approaches a f of x minus the limit as x approaches a of g of x. This rule works the same way as the sum law, but instead of adding, we subtract. It tells us that the limit of a difference is the difference of the limits. Technically, nag-subtract rata diri. So in this case, we can directly substitute this no kay wala man siya denominator and dili man ma-define nato function, so pwede na ta mag-direct substitution. So substitute lang nato si 2 diri sa atong mga x and then 2 squared minus 3 times 2 is just 4 minus 6. Then we came up with negative 2. So, sa constant multiple law for limits, this law says that if a function is multiplied by a constant, you can take that constant out of the limit sign. In short, constant can be pulled out front. We have this example. The constant 5 stays the same and we just multiply it by the limit of x. So, ang nahitabo diri since di ba, substitute man nato si 4 diri so it's just 5 times 4, 20. So the product law for limits, we have here the limit as x approaches a of f of x multiplied by g of x is equal to the limit as x approaches a of x multiplied by the limit as x approaches g of x. This rule says that when two functions are multiplied together, you can find the limits of each one separately, then multiply the results. So the limit of a product is the product of the limit. So nagmultiply ra ka diri ay substitute lang nato siya. So we have also here quotient. We have learned in our previous topic class na kani atong denominator dili gina siya pwede ma-0. Undefined man gud siya if ma-0 siya or di pud pwede na radical sa baba. So motong lang nag-conjugate ta. So, mura ra siya, pares sa silang concept. It's just that we're talking about limits lang. So, this means that when you divide one function by one another, you can take their limits separately, then divide them. But there's one important condition. The denominator cannot be 0. Take note of that one. Because again, division by a 0 is undefined. So, here are some evaluating techniques that we're going to learn later on. But first, let's talk about what is a one-sided limit. A one-sided limit looks at what happens to a function as x approaches a value from one direction, from the left or from the right. Well, if a graph suddenly jumps at x is equal to 2, from the left, the value might approach 3, written as the limit as x approaches 2. Kubantay mo na ay negative sign dira sa iyahang ibabaw. So, pasabot ana, approaching from the left. So, gikan sa left. Di ba sa atong Cartesian plane, pag gikan sa left, here, di ba mga negative ato ang numbers here? Pag ganon, diri padulong. Pag gikan sa right, kung nakabantay mo diri sa baba, positive pod siya. So, if these two are not equal, the two-sided limit does not exist. Let's discuss further, no? The limit is based completely on the values of a function taken at x value that is slightly greater or less than a particular value. A two-sided limit, or where limit as x approaches a of the function f of x, takes the value of x into account that are both larger than or smaller than a. So, both. Take note of the word both. Sa one-sided limit, it's either from the left or from the right lang siya. Takes only values of x smaller or greater than a respectively. So either lang sa left or sa right. Let's talk about continuity of a function. How do we know if a function is continuous or not? A function is continuous at a particular point if there is no break in its graph at that point. Many functions have the property that they can trace their graphs with a pencil without lifting. So, for example, kung mag-graph ka, kung dili nimo mabugto or dili mabugto ang imong graph or dili mo malift imong pencil, technically, that is a continuous function. So, here are some conditions that should be satisfied in order for us to tell na si function kay continuous. So, dapat kaning tulo masatisfy na siya. Ato ra nang balikan later on. Let's take a look at first this example. So, notice class that we have a denominator here, right? Kabantay mo kung i-direct substitute nato si 2, unsa may mahitabo diri sa denominator? Okay, mahimong 0. Dapat dili ma-0 si denominator. So, therefore, dili ta pwede mag-direct substitution. Unsa may pwede nato buhaton? Ang atong buhaton ani class, mag-factoring ta. This is how we answer no or evaluate a limit. Kung unsa may factor ani ni numerator, x squared minus 4. Iyahang mga factors are, kay unsa may napansin ninyo, pwede ta mag-cancel out sa numerator o denominator. ba? Diba? So, makancel naman si numerator o si denominator. Ang mabilin, kini na lang. So, i-substitute lang nato si x. So, ito lang i-rewrite again. Okay, let's plug in 2 sa atong limit. So, therefore, the limit of this function is 4. Simple ra no, dali ra kayo siya. So, kato lang, take note lang, if naatay denominator, make sure lang nga dili ma-0 si denominator. We have this example. So, here, wala man tayo denominator. Ang atong pwede buhaton is mag-direct substitution na ta. 35 minus 4. So, the limit of this function is 31. So, that is your final answer. Okay, let's take a look at another example. Okay. Unsa may na-notice ninyo? Okay, ang ato ang x approaching 3. Pero kung i-direct substitution na to si 3 dire, unsa may mahitabo? Mahimong 0 atong denominator and kana atong gilikayan. Anong gagawin? Factoring na pod. Kani kay kuan man ni siya perfect cube. Gamito na to tong property. So unsa man ang ato ang a, di ba? First identify sa nato unsa tong a diri a. Okay, I hope na remember pa ninyo basig na amnesia na mo dira a. Same ra na siya technique. Na lang siya limit nga tapa dira. Sige, this time mag-kuanta. Cancel out. So, naman tayo common nga factor sa numerator or denominator ato nang ipang-cancel para di maglaba tong ulong later on. Cancel man ni, okay? So, ang nabilin is x squared plus 3x plus 9. So, kana na lang ang atong focus. Pwede na din ta mag-direct substitution. Kay dili naman ma-0 atong denominator. Sige. Atong isulat. So, this is just 3 squared plus 3 times 3 plus 9. So, that is your final answer. The limit of this function is 27. Naa na pud tay denominator. Ang problema, ang atong numerator naapoy denominator. So, unsa may buhaton na to ani? Ang atong target is ma-eliminate ang denominator sa atong numerator. So, unsa may buhaton gani pag ingon ana ang case, mag-multiply ta og constant both sa ilaha para balance atong equation, no? Dili 3x. Mao na lang ni ang nabilin. Kay na-multiply naman ay na-eliminate naman nato atong denominator sa baba. So, ang nabilin diri sa atong numerator is 3 minus x over 3x times x minus 3. Okay, notice class, kaning sa taas, pwede na to ipagawas ang atong negative para maka-cancel out ta sa iyang denominator diri. Okay. So, nakakita na ta og kaparehas ni agnawong kani og kini. So, ato ning i-cancel. Okay, now that we have this, pwede na ta mag-direct substitution. So, that will be your final answer. The limit of this function is negative 1 over 9. Okay, next example. We have here the limit as x approaches 9. Kung ato siyang i-direct substitute, sa mahitabo, mahimong 0. And naglikay ta nga mahitabo na siya. Atong tan-awon og balik unsa atong pwede buhaton ani. Di man ta pwede mag-direct substitution. Mag-conjugate ta. Kuhaon ang opposite sign ani niya. Para later on, natay ma-cancel out. Okay. So, using FOIL method, this time class, ang atong i-FOIL method, kanilang si numerator. Kay para natay ma-cancel out diri sa baba. Makita na to later on. Ato sang i-perform. I-FOIL lang na siya. Plus 3x. So, sa may mahitabuan niyo, wala naman ni no. So, ang mabilin, x minus 9 over x minus 9. Kita ninyo nga function karon nigawas na ning sa numerator nigawas si x minus 9 and then napud ta x minus 9 sa denominator. So unsa atong buhaton? Mag-cancel ta. Ang mabilin 1 over square root of x plus 3. Okay, if nagwonder mo, ma'am, naalagi siya yung radical sa baba. Hulat sa ato sana siyang tiwason og solve. Kani manggod, pwede na ta mag-direct substitution using this kay ngano man. Si 9 kay masulod man siya sa square root. Sige, lantawa ha para mag-gets ninyo akong pasabot. So ang nabilin di ba diri kay 1 over square root of x plus 3. So atong i-substitute si x diri So unsa may mahitabo? Perfect square man gud si 9. Mo nang convenient siya kung dili na nato siya tandugon. So, 1 over 6. The limit of this function is this, 1 over 6. That is your final answer. Okay, for this next example class, same ra siya concept sa ato ang gibuhat diri sa example number 5. Atong numerator as a whole, naa siya denominator nga nay radical. So, ato sang i-eliminate ang radical sa baba. So, multiplyan nato sila both og 2 square root of x apil sa baba para ma-eliminate nato ning iyang mga denominator which is naa sa numerator. So, ang mahitabo, makancel man ning sa baba. So, mo na lang ning mabili. Okay, here, notice no nga naagihapon tay radicals. So, anong gagawin? Mag-conjugate na pud ta. So, unsaon pag-conjugate? Ato lang ning kuhaon ang iyang opposite sign. Kopyahon ra nato na and then just put the opposite sign. Don't forget to write the conjugate as well. Kay dili man pwede nga sa ibabaw ra ta mag-multiply, dapat na pud sa baba. So same lang siya concept kagaina. Di ba atong gibuhat kay atong gi-foil kay kanirang nasa ibabaw. Ayaw lang sa hilabting ning nasa baba para natay ma-cancel out later on. Sige, pakita nato para mas klaro. So, sa ganyan, may 4 plus 2 square root of x minus 2 square root of x minus x 1 over 2 square root of x times x minus 4 plus 2 square root of x. So, wala naman Ang mabilin kay 4 minus x all over everything kaning nasa baba. Kopyahan na lang na ninyo. Notice ang atong numerator, pwede na to ipagawa si negative 1. All over. So, kapansin mo, na siya'y nigawas nga parehas nga factor sa taas, sa numerator, sa denominator. So, makancel out na nato na. Ang mabili, pwede na ta mag-substitute. Since ang ato ang 4, perfect square man siya, kung ato siyang i-substitute sa atong mga naay square root, dili siya problema. We can easily evaluate na dayon. So, negative 1, substitute lang nato si 4 ha sa mga na x. So, that is your final answer. The limit of this function is negative 1 over 16. As a review, here are the properties of limit. The limit of a function is represented as f of x reaches L as x extends to a limit a, such that the limit as x approaches a of f of x is equal to L. The limit of the sum of two functions is equal to the sum of their limits, such that the limit as x approaches a of f of x plus g of x is equal to the limit as x approaches a of f of x plus the limit as x approaches a of g of x. The limit of a constant function is a constant term, such that the limit as x approaches a, the constant is equal to the constant. The limit of a product of the constant and the function is equal to the product of constant, and the limit of the function such that the limit as x approaches a, m of f of x is equal to m the limit of f as x approaches a of f of x. And lastly, for the quotient rule, the limit as x approaches a of f of x divided by g of x is equal to the limit as x approaches a of f of x over or divided by the limit as x approaches a of g of x, where g of x is not equal to 0, or our denominator should not be equal to 0. Now, let's talk about the piecewise functions. A piecewise function is nothing more than a function that is broken into pieces, such as this one, and which piece you use depends on the value of x. So, in the absolute value, example, we will use the top piece if x is positive or 0, and we will use the bottom piece if x is negative. If our x is a positive number, so kani nga function ang atong gamiton. And if the value of x is a negative number, kani nga function ang ato ang gamiton. Going back to three-step continuity, here are the conditions that should be satisfied. These three conditions should be satisfied in order for us to tell if the function is continuous or discontinuous. So what is a discontinuity? The function of a graph which is not connected with each other is known as a discontinuous function. A function f of x is said to have a discontinuity of the first kind at x is equal to a if the left-hand limit of f of x and right-hand limit of f of x both exist but are not equal. Take note of this. Both exist but not equal. F of x is said to have discontinuity if the first kind from the left at x is equal to a if the left hand of the function exists but not equal to f of a. So later on, we will further understand this using some examples. So here are the types of discontinuity. We have the jump discontinuity, the infinite discontinuity, and the removable discontinuity. So let's discuss further what are these types of discontinuity. A jump discontinuity is of two types: discontinuity of the first kind and of the second kind. Discontinuity of the first kind, where the function f of x is said to have a discontinuity of the first from the right at x is equal to a, the right hand of the function exists but not equal to f of a. In jump discontinuity, the left hand limit and the right hand limit exist and are finite but not equal to each other. Okay, they exist but dili sila parehas og value. Discontinuity of the second kind, a function f of x is said to have discontinuity of the second kind at x is equal to a if wala sa ilahang duha, from the left hand limit at x is equal to a nor the right hand limit f of x at x is equal to a exists. That is the jump discontinuity, and the graph looks like this one. And take note that this is non-removable. So for the removable discontinuity, a function f of x is said to have removable discontinuity at x is equal to a if the left-hand limit at x tends to point a is equal to the right-hand limit at x tends to point a, but their common value is not equal to f of a. A removable discontinuity occurs when there is a rational expression with common factors in the numerator and denominator. Since these factors can be cancelled, the discontinuity is removed. Okay, among the three class, kanilang si removable. kani non-removable, and this one as well, non-removable. See infinite discontinuity. For infinite discontinuity, either one or both right hand and left hand limit do not exist or are infinite. It is also known as essential discontinuity. Whenever the graph of a function f of x has the line x is equal to k as a vertical asymptote, then f of x becomes positively or negatively infinite as x approaches from the right or x approaches from the left. Then function f of x is said to have an infinite discontinuity. To fully understand these definitions and theories, let's take a look at this first example. So we have here a piecewise functions. So our goal here is to check whether this function is continuous at x is equal to 2 and x is equal to 3. So let's first identify f of a. Step 1. Does the function actually have a value at a? So notice nga si first function dili included si 2. So we cannot use this one. So sa second function, we have here 2 is less than or equal to x. So, kani pwede na ito gamiton using this function. In here, 2x plus 5, x is greater than or equal to 3. So, kani dili po na ito siya pwede gamiton. Si second nga function. So, let's try to plug in. And then 2. Okay, that is for our first step. Okay, for the second step, let us identify if the limit exists from a left to right. Okay, let's go back to our piecewise function. Since less than 2, numbers lesser than 2 are negative numbers na biya. So, kanya itong gamiton na function for the function approaching from the left. Okay, so equal sila no, so that's a good thing na ay chance nga nag-exist or continuous ang ato ang function. If approaching from the right. So if the limit approaching from the right, kung nag-exist pa pud ba siya. So balik ta diri atong lantawon unsa na pud na function ang ato ang pwede gamiton. So in this case, atong pilion is kani since our x is less than 3 but not lesser than 2. Okay, approaching na pud ta from the right. Okay, now that we see that these three are equal, so therefore we can conclude that this function is continuous at x is equal to. Okay, so humana ta sa 2. Now, ato na pong i-test si 3. Okay, same process lang but this time we will be using 3. So, among these 3 functions, ini atong gamiton since x is greater than 3. This one, not included si 3 diri kay less than man, no? Less than x man siya. So, this function ang atong gamiton to check if our a is defined. Okay, that's for our first step. Okay, now let's check if approaching from the left or from the right, kung nag-exist ba siya or equal ba siya sa ato ang first step. So, approaching from the left, ang ato ang gamiton nga function is this one. Nga naman, it's because 3, less than 3, si x diri as. Okay, approaching from the left, is equal to 7. Okay, notice class nga dili sila equal but x approaches from the right. We notice that x approaches from the left and approaches from the right is not equal. So therefore, this function does not exist. Why jump discontinuity? Because the limit exists and are finite but not equal to each other. So nag-exist silang duha, approaching from the left and approaching from the right. It's just that they're not equal to each other. So that is the first kind of discontinuity. That's it for example number 1. Proceed with example number 2. Now we have this piecewise function 2x plus 5 where x is less than negative 1, x squared plus 2 where x is greater than negative 1, and we have the function 5 or our constant 5 which x is equal to negative 1. So here, we'll focus on negative 1 lang jud. Wala na may lain values, right? Negative 1, negative 1, negative 1. Unlike the first example that we have si 2 and si 3. So in this case, we only have negative 1. Okay, let's start with the first step. So among these 3 piecewise function, no, kanilang ang equal to 1. So this function natong gamiton. Okay, for the first step, Mora na siya. Let's leave it that way. Step 2, let's check if approaching from the left, kung nag-exist ba siya. Unsa man nga function ang atong gamiton since approaching from the left man siya. Technically, kaning first function. Since ang atong x is less than -1. So, let's use that one. Okay, the limit as x approaches -1, we came up with 3. Now, let's take a look at from the right. If approaching from the right. So, if approaching from the right, let's choose this function since our x is greater than -1. So, kani atong gamito na function. Okay, from the right na pod. Okay, so notice that our limit approaching from the left and from the right is equal to 3. So, therefore, nag-exist siya. The function is existing. We have a problem since atong f of a, di man sila equal sa each other, di ba? So, di ba dapat ang kaning tulo kay equal sila for us to consider that is continuous. So, our conclusion here, it is a removable discontinuity because si left and si right tends to point at A but their common value is not equal to f of A. So, notice that in our piecewise function, equal si limit as x approaches -1 from the left and from the right, but not equal to our f of a. Because -1 is not equal to -5. So, diri siya na fail sa step 1. And take note that these conditions, all three conditions, must be satisfied for us to conclude that it is a continuous function. But in this case, only si left and si right lang equal. Si f of a is dili siya equal. So, it is a removable whole or removable discontinuity.